Some of the operations shown on the table and radial arm saws are for photographic clarity. We strongly recommend that you work with the guards in place. You have probably thought of building some cabinets for your home, but you may have been discouraged because the job seemed too complex. All of the cabinets you see here are built using similar construction.
Small cabinets like these have something in common with large cabinets like these. These are both faceplate cabinets. That is, this front is a faceplate of the cabinet. This is what we would make first. Now, when you start building cabinets, one of the first things you want to do is start with a drawing. Many books will provide plans for drawings, and not surprisingly, you see the same project here that I was pointing out. The plans may look a little confusing when you begin, and we hope to clear that up for you. One of the first things you want to do is study the prints carefully and see what you can learn from them. See if you can identify some of the various problems or anticipate those problems. From that, you'll want to develop what we call a faceplate drawing. This defines the front of the cabinet or the faceplate itself. Now, let's take a look at a faceplate for a minute. As you can see, the faceplate is the same here, and it defines the overall dimensions of the cabinet. After we've developed the sketch and tell the overall dimensions, some of the other things we have to consider is what type of joint we'll use to fasten these various members together.
Cut the parts for the faceplate. Cross-cut on the radial arm saw and rip on the table saw if possible. Make the parts a little wider and longer than necessary. The edges may now be planed lightly to remove saw marks.
We're inspecting our faceplate stock here to identify the best face, and that's the face or the part that we'd want looking toward the outside of the cabinet, and for defects such as this one here. This defect on the edge is a little bit of the edge of the board itself. We'll use this piece in the cabinet, and what we'll do is we'll put it in the cabinet so that it'll be up and oriented away from the inside of the cabinet and no one will see it. So we can make good use of our material. This piece here has a little knot on this side and a little knot on this side. I'll probably choose this to be my exposed face because when I cut my lap joint, this will be removed and the other part of the cabinet will hide it. It's important that you look over your stock because when you buy your lumber, usually you don't see things such as this wind shake that has been generated as a normal defect in the board, and as I ripped the board open, these became obvious. This particular piece has some checks and shakes in it, and these types of things are normal in our boards. They're really not useful for the cabinet, but I tried to cut them short to minimize my waste. I'll save these pieces because I'll use those to set up my table saw and radial arm saw for future cabinet work or for the joinery that we're doing. You'll see that later. One of the reasons we're belt sanding our boards is to remove these mill marks. These lines or waves in the board are generated by a planer that smooths the board. Now, I've got a coat of finishing oil or like a penetrating oil on here to help show you what these will look like. Now, they aren't visible to the naked eye or the untrained eye for the most part, but the more you work with wood, the more visible they become, and as soon as you put stain or finish on, they become very visible. So we want to remove those as one of the first things, and we'll go to the belt sander and belt sand only the good faces of these pieces.
The exposed faces are now rough sanded to remove mill marks. Roger sands only the exposed faces.
I've included one wider board here. Many people, when they begin working with a belt sander, experience dips or divots on the side of the board. If you work with a wider board, That'll minimize the chance of that occurring, and then you can cut your faceplate strips from this later on. So let's go ahead and sand this one off. And you can see I didn't have any trouble arcing here. The more you work with this, the less problem you have. Now I'll go on to my last piece of faceplate stock here.
Roger has decided on lap joints for the corners of his faceplate.
I've decided on lap joints for a couple of reasons. First of all, when the shoulders butt together, they give you a nice, tight, secure joint. Also, there's a lot of surface gluing area here, which makes the joint very strong. The line looks very clean when you work with it. Another interesting thing about using lap joints is that the horizontal members go from end to end, so working with the drawing we don't have to do any subtracting. We know that these members will be 15, and we know that the vertical members or the stiles will be 20.5. This makes layout and planning a little easier. There are some other joints that you could use, and I'd like to spend a minute or two showing you those so you'll get an idea of other ways that you might be able to work depending on what tools you have available in your shop. One of the real common ones is the dowel joint. The dowel joint uses two cylinders of wood that are fluted, and they are pushed into the two units or two members so that when they are clamped, there is something that joins them. Again, this is an easy joint to put together. There are jigs that you can use, and they're available through most woodworking houses, supply houses. The dowels themselves are actually drier than the wood we're using, so they absorb a little glue and expand in the joint. The flutes allow the glue to escape as they're pushed in, so it doesn't act like a hydraulic valve. These will swell a little bit. When you buy these, you'll find that they're usually supplied in a plastic bag. Keep them in that plastic bag until you're ready to use them. That will keep them from absorbing the moisture in the air, and it'll give them that ability to expand when you work with them. Another interesting joint is this one here that uses screws in a pocket fashion. What happens here is we drill a pocket into the wood, and then a screw is driven in through here. Now, these little screws are hardened, and they will cut their own threads. They have a little bit of a drill point on them, and they have a square drive or a Phillips drive. A square drive is nice because it gives you almost a wrench-like capability as they're driven. You would use a power driver to drive these, such as a drill motor or a drill driver. These have various devices that allow you, or there are various devices that allow you to drill these holes at an angle very easily, and these are also available through most woodworking supply houses. Another joint that might be used is what we call the plate joint. The plate joint uses a small football-shaped plate, or sometimes referred to as a biscuit. A special machine is used to cut this slot into the wood, and what it does, it allows this to move slightly in a lateral fashion so that should the pieces be offset a little bit, you can drive them into position. Now we're using 2-inch faceplate stock, which will actually leave a slight slot at the bottom of the joint. And this could be a little bit distracting for some people, but for production work you'll find that this is very common. If you made wider faceplate members, this would not be a problem. So should you work with that, something to consider. One other type of joinery is what we call a mortise and tenon joint. The mortise is a slot, in this case it's a through slot, and the tenon, which is a male member that slips in like so. This is sometimes referred to as a slip joint because they slip together like so. They make an interesting end grain effect, and they display the joinery. Now in some cases these will be blind, and I would like to show you a faceplate that shows both types. This is a blind mortise here in that it doesn't go all the way through the piece, a blind hole. And this piece is a little shorter, that is the tenon is a little shorter, and it's been reduced on both sides. This one is the entire width of the piece, and this has been shouldered, the idea being there it wouldn't be visible at either end. So you could actually use this at both the top and the bottom of the faceplate as well. You would probably make this a little, these shoulders would come in a little further at the top and the bottom, and that would give you more end grain to give this joint rigidity. So should you wish to plan one of these out, you would have to drill this out either on the drill press, or you could use a doweling jig with a series of holes and then clean it out with a chisel. So this is another way of planning out your faceplate.
The depth of the dado is set for the center of the work.
I use this piece for my layout, and to control the distance I have to be from the fence, I will use my layout line and I'll lock the fence accordingly. Now when I put my workpiece up here, I can see a little bit of that dado head sticking out. That's good because when I put these together, that'll leave a little bit of end grain protruding so I can trim it off evenly with the workpiece. I've got a glued up faceplate here, and this shows you how the pieces should be oriented. In other words, on the front of the cabinet, the outer pieces, which are the stiles, go from top to bottom of the cabinet, and the rails, the horizontal pieces, go from stile to stile. So what I've done here to help me lay out my faceplate and determine where the joints ought to be, I've got my parts set out in the same way. In other words, these pieces are over, and the stiles are over the rails, so we know where they need to be. Now what I've done is I've marked with an X where the lap joints need to be cut. And what this allows me to do is go to the saw without any confusion. That is to say, I know which side of the board has to be cut. If I didn't do this, I might have the joinery backwards so that it would look like so, and all the bad sides would be exposed. We're going to try to avoid that, and you're going to find that a little planning at the bench goes a long way to helping you get good results on your first attempt. Now there's a few things that we can stretch this a little further. This is the nightstand. Here's a faceplate for the hall chest. It's a little bit different. We have the same stiles on the outside, but we have a center stile now. The difference is there's a break here. That is to say, the center stile is broken by the rails. The rails always go from end to end or from stile to stile. So we've got a little bit different orientation here. So this is going to be a little harder to lay out the parts, and there's going to be more thinking. That is to say, this piece is different than this piece, so we've got extra parts and the cuts are a little different. So I think you can see that there'd be more confusion if we didn't do some of this marking in the beginning. So I'm going to set those parts out and beginning doing that before I take them to the saw. Again, a little planning at the bench makes all the difference in the world.
On larger pieces, lap joints may be easier to cut on the radial arm saw. The radial arm saw supports the stock. You don't have to contend with gravity. The faceplate is now ready to be tested for fit. Always fit all of the joints together without glue to make certain that the fit is good. A dry fit will also aid in the subassembly by presetting the clamps to the setting which will be used during the glue-up. After the dry fit, we are now ready for gluing up the faceplate. Be well prepared by having all materials needed, ready, and within reach. A gluing brush is recommended for use. This will help to keep glue off your hands during the subassembly. Do not over-tighten the clamps. A well-fitted joint will not require over-clamping to ensure a good fit. Check for squareness and position pieces as needed to keep the faceplate square.
You might have noticed that I haven't put any newspaper out here to protect the bench, so I'm using the glue very carefully, and I'm also positioning these clamping pads well away from the edges so when I try to pull the parts together they don't interfere with the action. I'll just put this clamp on lightly to pull these together. These clamping pads protect the workpiece. You wouldn't want to damage the front of the faceplate with clamp marks, so we're planning well ahead to minimize any of those problems. It's much further to go forward in woodworking than it is to go backward.
The radial arm saw may be used for cross-cutting the cabinet, sides, bottom cleats, and nailing strip. The two sides are cut to identical length. The nailing strip and bottom are also cut to the same length. The bottom cleats are cut to the width of the sides. The glue is cured and Roger has removed the clamps from the faceplate. A little bit of wood is now trimmed from the lap joints to make the joints uniform. Work carefully with the belt sander. Try to keep the edges square. Too fine of an abrasive will burn the end grain.
The sanding went real well here, and it's nice and uniform. I didn't rock the sander, so I've got a nice flat surface here. If you're not that good with a belt sander, one other way you might do it is with a router using a laminate trimming bit. Now this bit has a ball bearing and a cutter that are exactly oriented to the same size. So imagine if this ball bearing ran along here like so, it would actually cut this off evenly, and the bit gives you a nice shearing cut. Now we wouldn't do it in this fashion. What we would do is we would clamp this to the workbench like so, and then we would work in the horizontal plane, keeping our router squarely on the workpiece, going from left to right as we face the work, and so forth. This is another way of cutting it off, and depending on what tools you have and how relaxed you are with one tool or another will determine just how you do it. The nightstand is 24 inches tall, so the sides are 23 1/4 high. That allows 3/4 of an inch for the top per the plans. We've kind of laid out our sides and our faceplate in matched grain color and the best looking grain for the outsides of the cabinets. We've marked them with an F, so this is the front of the two pieces, and the lines up means that this is up. That way these little defects at the bottom will be hidden by the base molding. So a little planning has gone into this. Now we're going to talk a little bit how we determine where the inside parts of the cabinets go. If we turn this over like so, you can see that some of the defects will be hidden up where the drawer is going to be, and they'll be clear of the piece. We can also say to ourselves, if we line the faceplate up with the top of the cabinet, which is where it's going to be, we now know exactly where the floor will cross the sides. This can help us lay out the other parts, and good planning goes a long ways in this. So let's take the other side that I've already laid out and show you a few things about how they're happening. When we line this up like so, we see that the floor actually goes across here like so. There will be a cleat here to support the floor and two lookouts or pieces coming this way to support the floor in the, across the front of the cabinet. So what we've done is we've cut some parts here, and this part would go like so to support the floor, and these two would come off like this. And now the other piece would go on the mating side, and of course they'd all go together. This third piece that's exactly this size would actually go up here, and this supports the back of the top and helps give us some anchorage for the back. This line here suggests where the back will go. Now, one of the interesting things about this is, just like you were taught to prove your arithmetic in school, we can prove our arithmetic in woodworking. How do we know how long those pieces need to be that go from left to right? Well, if we put these pieces together like so, we know in fact that the bottom, or these cleats, should go all the way over to this side. Well, let's take a look and see what happens. When we put this piece up in position like that, we see that we've got about an 1/8 inch extra, and that's nice. First of all, that leaves us a little bit to trim off the faceplate, which is far better than having it the opposite way where we'd have to grind off part of the cabinet side. So this is good planning, and we can do all sorts of figuring in our head, but after we've got the figures written down on paper, we can prove our arithmetic to make sure that things are right before we start gluing and nailing. This is just good planning and good sense. One other thing that I would like to point out, that these three pieces are the same length as the floor will be. So all of the horizontal pieces are exactly the same length. This means that you can hold a cabinet in a square fashion to keep it from leaning in and out very easily. So from this point, I think we're ready to consider gluing up and clamping our cabinet together, the overall assembly. So from here, I'm going to get prepared to do that, and I'll be back to do that shortly.
The cabinet may now be glued and nailed together. First, the bottom cleats are glued and nailed to the bottom of the sides, flush with the bottom edge.
We've nailed this cabinet together with regular common nails, and we've done this just as you probably would do in a small shop where you didn't have pneumatic nailing equipment. These nails are roughly an inch or an inch and a quarter long, and they'll allow you to nail the parts together. Be careful that they're not too long, or if you nailed this way you could come out the side of the cabinet. So a little bit of caution there. Now, we couldn't really use these small nails to nail the faceplate on the cabinet because the heads would show. So we'll use a finishing nail. These finishing nails have a much smaller head, and that allows us to bury those and use some wood filler on them. Now, if you've ever tried to drive nails in oak, you know that they usually bend after about the second swat. We're going to compensate for that by drilling a hole. To drill a hole the exact size, we're going to take a finishing nail, and we've cut the head off this one with the wire cutters. We've then taken that nail and we've chucked it in a drill motor. So now this will become our drill driver. This will drill the hole, and it will not drill as deep as the nail, so the last portion of the nail will be set in the wood and do some real holding. Now I'll demonstrate how this nailing is going to be done in this corner here, because we're going to set the nails on this end very low so the face molding will cover, the base molding will cover this when we install or after we finish up here. So we're going to hide these lower nails, and then I'll go around and show you how to handle the rest of them. Nails in the faceplate look best when they can't be seen or are least visible. What we're trying to do when we nail along this faceplate is select a position where the nail is least visible. With oak we have what we call an open grain wood, and we've selected a spot where this X is in the open grain area where we're going to drive the nail. That area will be darker when we stain it, and it'll be much easier to hide the wood filler. So I think I'm ready to drill this hole. That takes care of that. We'll fill this and eliminate it. Now, one other thing that we didn't talk about that's important is the fact that we use chalk on the sides of the cabinet. We don't really need to know that the front is there anymore because it's pointing that way. This is the beauty of using chalk. You saw me put these corner blocks in with a pneumatic nailer. That looked awful simple. Not nearly as easy to clamp these unless you've made a notch like this in the sides of the corner block. This gives us some clamping room so that we can put a parallel clamp on here or other type of clamping device to pull this together. I'm going to demonstrate how this would be done.
For extra strength, corner blocks are glued from the faceplate to the cabinet sides, and from the cabinet sides to the nailing strip in back. The blocks are needed for extra cabinet support, as well as squaring the cabinet and providing an area to which the top may later be secured. The notches cut into the blocks provide an easy clamping surface.
We've got a slight lip on the side of this cabinet, and in kitchen cabinetry that's desirable because then when two cabinets are butted side to side, the sides of the cabinets never hit, and that allows for any deviations in the wall. In this case we want a flush edge on here, and to eliminate what little bit of an overhang we have, we're going to route this off. Now we've clamped the cabinet so it won't go anywhere, and we're ready to route. We're going to put a rabbet around the back of this cabinet, and I've got it clamped so we can do this with the router in a minute. But I want to point out something. Notice how this rear support has been recessed a bit. That way there will be no nails in the path of that router. Up here, this rear nailing strip, the nails are about this level here, so we've cleared the router area with no problem. We don't want to take a chance on having that router bit hit a nail. So we're ready to go. We'll start about here and we'll take it around. I've got my bit preset and I've got my workpiece clamped. Now I've got an arced corner here, 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 and here. I'll have to mark those and square those up. So I'll show you how that's done in just a minute.
The back is cut slightly smaller than the measure of the routed area. 1/16 on all sides will be sufficient to ensure a good fit. The back also helps to keep the cabinet square. Recess slightly so it's not visible from the side of the cabinet. The back is glued and nailed in place.
In looking at this piece of plywood that we're going to wrap with the solid stock, we notice there is some tear out along this side here. And we're going to check the other side to see if it's any better. And as luck would have it, this side is perfect. We're going to check it out and see what looks to be the factory corners. This looks like it's one of the factory corners, and we're presuming that's a perfect 90-degree angle. So we'll put that forward. This is how the parts will fit together, and we'll mark them as such. Also notice that the grain color is quite nice here, so this is going to make a very pleasant top. I'll mark these. That'll give me a little idea of where they go together. You might notice that these are a little long, and that's good, because if I make a mistake on my miters later, I could cut it again and move it up this way 2 or 3 times, and that'll give me a little better opportunity, a couple chances to get a perfect miter. So I'm going to take these parts now, and I think I'm ready to go to the table saw.
Once the pieces have been cut to length and ripped to a width, a groove will be cut on the inside edges of the solid stock and the side and front edges of the plywood. Cut the groove just slightly larger than the spline, which will be inserted in the groove. The The table saw setup for cutting miters is very important. Take time to make sure that the miter gauge is set 45 degrees to the saw blade. An accurate 45-degree triangle may be used for checking the angle.
When you have one miter gauge, you can set one to a 45-degree angle with a drafting square, some other device. Most miters are 90-degree included angle, and if you have the benefit of two miter gauges, we can set complementary angles. For example, this might be off just a little bit, but if this square is a perfect right angle, and you have the luxury of two miter gauges, you can now set the mating miter perpendicular to the one you've set. Now, as long as you cut one side of the miter on this side and one side of the miter on this miter gauge, you'll find that you have 90 degrees included. So it makes miter cutting much easier. A little tip, something that could be useful to you in just about any type of mitering you do. We've cut one of the miters, and I've marked the other one for the top at the bench, and now I've got my line laid out, and here's where I get the benefit of that second miter gauge, because now what I can do is cut this complementary miter simply by moving over like so. So I'm going to remove this miter gauge, get the setup right, make the cut, then I can get back to the bench and do my assembly. While I was at the table saw, I cut the groove that we needed for the spline, but I also cut the left miter. Now, what I've done is clamped this piece so the short point is at that intersection of the two corners, or of the corner, I should say, the two edges. When I butt this up, I'm satisfied that that miter is good. Now, I've got enough length here that if I wasn't satisfied with that miter, I could cut it again. But since I am, I can now come over to the opposite side, take my marking knife, and mark the short point of this miter. I'll take that line now, or that point, and I'll extend it with my combination square. So that now I have a line on here that I can follow at the table saw. So I'm going to take this to the table saw and cut it, and I'll be right back. Looks like my layout line was right. The fit is good. So I'm going to stop now, get some clamps, and get ready to glue this up. Well, now that I've clamped the front on and glued it, I've got it positioned correctly, and I just finished cutting this miter. Check the fit. And again, I'm pleased with how it's going to clamp up, so I'm not worried. Everything's ready, and I'm going to continue from here and just go ahead and glue and clamp the parts. So I'm going to turn this 90 degrees like so that I can work with the clamps a little bit better. Keep my pieces oriented. Apply some glue to the groove as well as the edge. Good to get plenty on the miters. Now if my miters don't line up evenly here, I can put a clamp on those and pull them into a true plane. Now if the metal were to touch the glue in that and the wood at the same time, it could discolor it. So I'll put these on here. I may have to knock these off and sand after I'm done, but I can just, with these clamps, pull this into an absolutely true plane so that my miters line up nicely. I'll worry about the consequences of shaving those off afterward because I'm happier to have my miters line up. Now I'll leave this cure, and once the glue is cured, I can trim this. We'll do all of those at the table saw. So I'll set this aside and clean up the shop for now.
A simple keying jig may be made for cutting keyways in the ends of pieces joined together. The keying jig is made so that it will slide along the miter slot. Plans for this jig are included in Roger's book, Table Saw Techniques. Using the jig, cut the keyways on the edge bands. The keys are cut below the center line so that they will not be cut away when the edge is shaped. Keys are cut, fitted, and glued in place. To shape the edges of the top piece, the molding head may be used on the table saw. Always start by making light cuts. Using this same setup on the table saw, the base molding may be shaped. All edges may also be shaped with the router. End miters are cut on the base molding. Route this stock when you route the top.
We've glued up the front and then this side, and if you've ever done any gluing, you've probably had the experience of glue smearing all over and the piece moving around on you. So a little tip on that is you're going to have to put plenty of glue on the miter, but when you glue this side, hold the glue down a little bit so any squeeze out won't come out above the edge of the piece. Now when I position this, I'm going to work carefully so that I have the front lined up, and I'm going to hold the back low and bring it into position. Now I've used a spring clamp to pretty much hold my position. That gives me a chance with just a little hand force to move this around to get it exactly where I want it. Sometimes they creep on you a little bit, so you have to fool with them a bit. But once you've got a piece where you're satisfied, you can then snug up one of the clamps. You can also tap things lightly if you have to, being careful not to dent the material. I can now pull the spring clamp. Gently move that piece a bit. and now I've got it clamped all the way around. Now if these pieces were warped a little or you had a twisting problem, what you might want to do is this. Drive a couple screws in from the back and pull these pieces down tight. Fortunately, we don't have that problem here. Everything is snug. We got nice tight lines. I'm real happy with it. I'm going to just leave it as it is, let the glue cure for the appropriate length of time. Then I can pull the clamps and work from there. So let's leave it for a while. We'll come back to it and do the final touches on it.
After the wood filler has dried, sand all outer surfaces carefully. A small palm sander works well for the final sanding. Sand in the direction of the grain. Do not oversand the plywood. The top veneer is thin.
The rough sanding's done now, and I think you recall we put these triangular blocks in the cabinet to help pull it into a square plane or a square piece when we were assembling. We're going to use these blocks again to fasten the top. What we'll do is drill holes in there, and we'll use some very fine threaded screws to attach the top. When you attach the top, there's a few things to remember. First, you want to center it correctly so that there's the same amount of reveal or overlap on the three sides. The back will be flush. The second thing you want to do is mark your holes carefully, and then be sure when you drill the pilot holes that you don't drill through the top. Put some tape on your drill bit or something to limit the depth of cut. That way you'll have a better looking cabinet. Right now I think we're just about ready to start considering the next steps, door and drawer construction and possibly finishing. So we'll leave it at that for now.
The fully assembled and sanded cabinet is now ready for a door and a drawer. Future video modules will discuss door and drawer construction.